Hello everyone, hope you all are doing well. My name is Kamlesh and today I'm going to teach about the atomic orbitals and subshells, and we are going to understand the structure of the atomic orbitals. Basically this is a part of chemistry we studied during the 11th class in the second chapter, atomic structure. So I'm not going to teach the whole chapter. Right now I'm just teaching a specific portion. I hope you will like that. So first thing is like atomic orbitals. So since we know that like electrons has a dual property, first one is like wave nature and the particle nature. So it's very hard to exact the location of the electron, like kind of impossible thing that where is an electron at a certain time at a particular time. So the regions where the electrons are found, basically we call them as a atomic orbitals, and these things are also called as like the quantum states of the electrons. Now I will try to explain that what I'm trying to say, because this is just a theoretical portion. I just want to describe you that what I'm trying to say, because it's a little bit complicated, because as you know, like electron position is very hard to identify. So just give me 1 second. So let us assume that this is a nucleus of an atom, and I will like circle this portion with the dark little bit so that you can understand that what I'm trying to say. This is the like nucleus portion, and we already know that in the nucleus there are two things. One is the protons, and another one is neutron. And along with the proton and neutron, we call it as a nucleons. So there are some subshells and shells which I'm going to do right now. Like surrounding the nucleus, there are different shells, and in that shells there will be subshells and then orbitals. So basically, I'm trying to say that you can see like here there will be electron, like it will rotate, it will revolve around the nucleus again and again. So like that electron is revolving at different time. So it's very hard to identify that at which time what will be the position of the electron. So to describe that, to brief that, we understand that orbitals is the portion where electron can find. I'm just going to write that here, like in the nucleus. Sorry, just a second. In the nucleus there will be two things. One is will be the proton, and the second thing will be neutrons, and both of them will give nucleons. Okay, so we need to also understand that you can see these like the shells. In that there will be the electron, and specifically in the shell we will say orbitals is the portion where we can find the electrons. So I will write that as well, like in the orbital we can find the electrons. Electron will be present. So this is the thing which I'm trying to describe. The first thing which I had told you, that electron has two properties. One is the particle nature and one is the wave nature. So it's very hard to locate the electron at specific time, at specific position. So we just say that electrons revolve around these shells. Okay, so this is the first thing. And you also need to remember that nucleus has a two part. One is the proton, another one is neutron. And along with the proton and neutron, they form nucleons. And in the orbitals, there will be the electrons. So you need to understand this portion as well. Now let us study the further parts. So within an orbital, there will be like two electrons with the opposite spin. If first spin of the electron is will be plus half, then the second electron spin must be minus half. The thing is that let us assume there is a one room, and in that there will be two friends. So in that room, only two persons can occupy because the space of the room is not big enough. So like if the third person will try to come, so the two person will not allow him. So in one room, only two people can stay, and in that as well, they like live in the opposite portion because it's very hard. The space of that room is very less. So in the similar way, electrons like occupy in one orbital with opposite spin. If one is plus half, then another one must be minus half. Now orbitals are grouped into subshells, and the field of study is called as quantum mechanics. So what I'm trying to say, like the thing is that, just a second. First of all, let us understand about the subshell as well. There are three types of subshell. I'm writing. There are three types of subshell. The first one is as subshell. The first one is as subshell. The second one is p subshell, and the third one is d subshell. And then fourth one, we will not talk too much depth about that because it's beyond our course as subshell. So we need to understand that point, that if I will try to draw that subshell, then I will say that in the s orbital there are only one orbital. Like as subshell there will be only one orbital. In p subshell there will be three orbitals. In d subshell there will be five orbitals, and in f subshell there will be seven orbitals. Like this. This second. So in the p there will be three orbitals. You can see right now, and in the d there will be five. This will be the first one. This will be the second one. This will be the third one, and fourth and fifth. If I talk about the f orbital, there will be seven orbitals. First, second, third, fourth, fifth, sixth, and seventh. So we need to understand that, like I was saying, that in one orbital there will be only two electrons with the opposite spin. So if this is will be the electron, the first spin of this electron, let us assume it's plus half. It will be plus half. If this one is plus half, then the second electron spin must be minus half. Should be minus half. That this spin will be minus half. The same will be in the case with the p orbital. Like, but the first of all we have to fill one student in each orbital. Then after that we can fill the another electron with the opposite spin. So this is how we can fill the electrons. For the S subshells, I just want to notify that S mean for spherical, and P mean for principal, D stand for diffused. And so these three are the like in your course, and we're going to study about this. For the F orbital, it will be like beyond your course, and S stand for spherical, P for principal, and D for diffused. Now let us understand about this shape, like the how S orbital look like, how P orbital look like, how D orbital look like. Now you can see atomic subshell, like the S subshell. So there'll be like three subshells as PD. You don't have to like study about the subshell right now. So in the S subshell, it's the shape of the S subshell is spherical, and there's only one orbital in the S subshell. The electron will be located anywhere within the sphere. You can see this is the sphere. So the electron will be located anywhere, but not outside the sphere. Like if I will try to draw the coordinates of that sphere, like this one is the x-axis, this one will be the y-axis, then one z-axis which will be like above and below the like towards the observer and away from the observer. So the electron will only be like in the sphere itself. It will not lie outside the sphere. So what I'm trying to say that, like if I talk about the particularly as subshell, so let us assume with the coordinates, like this one is the y-axis, this one is the x-axis, and the third one is the z-axis. But the thing is that you need to understand that, like let us assume this red pen, this is the x-axis, and this black pen, this is the y-axis. But if I try to describe the z-axis, so it will be like towards the observer, like towards yourself, and away from the observer, like towards me. So that's why like we cannot draw that z-axis in the one plane, like this is the plane, so we cannot draw in this plane. So we have to describe it by drawing it like at the incline, but it's not inclined actually. It is the above from the observer and towards the observer. So like if I assume like this portion, uh, this point as a like plus x-axis, then I have to assume this as a minus x-axis. If I'm assuming this one is the plus y axis, then this one is minus z. I'm also writing here, but before that, let me copy this portion. Del with three axes, x, y, and z. We are going to study in that one. Just a second. I need one more. Okay, so let us understand the thing. If I'm saying that this one is x-axis, this one is y-axis, and this one is z-axis. I'm trying to say that if you are assuming this one is a plus x, which we do, then this portion will be minus x-axis. If this one will be plus z, then this one will be minus z. If you are assuming this vertical line as a plus y-axis, then this one will be minus y-axis. So I'm trying to say that like the shape of the s orbital is spherical and like this. So this portion in that sphere, the electron will lie. I will also highlight this portion with another color, so you will get a better understanding. So that this portion, the electrons will lie in this portion. If I talk outside from that, like if I say in that space will electron will be found, then I will say no. In this place, no. In this place, no. But if I say at this portion, then we can, there's probability of finding the electron. The orbital is the space where you can find the electron. So there's the probability of finding electron. So you can find like there's some portion in the plus x-axis, plus minus x-axis, plus y-axis, and minus y, plus z and minus z. There is a little bit electron finding probability. So this orbital is basically like shape of the x orbital, shape of the s orbital. Sorry, I will write down here as well. S orbital. Now let us understand about the p orbital. It is also like a little bit different from the s orbital. If I talk about the p orbital, the shape of the p orbital is dumbbell shape. Like we do exercise in the morning with the dumbbell. So that shape it is. And I already mentioned that the like in the p subshell, there will be three orbitals. And if I name them, then there will be like px axis, py, and pz. So p orbital, like the shape will be like two balloon like, or maybe like you can say dumbbell. When there are three orbitals in the p subshell, denoted as a px, py, and pz. And if you see like if you are moving from the s to p, p to d, then the energy of the p orbital is much higher than the s orbital, and the energy of d orbital is much higher than energy of p and s orbital. But we already know that if the energy is high, then stability is low because both are inversely proportional. That we will also I will discuss and describe that thing. But if you see right now, like this is the px orbital, then the electric probability is only in the x region. If I see like py orbital, then you can see only in the y-axis. And if I talk about the z-axis, then electron probability only in the z-axis. Let me describe that one as well. But first of all, we need to understand that like this portion I was talking about, that these are the we have three orbitals. So the first one is px orbital, this one, and second one is py orbital, this one, and the third one is pz orbital. And the similar case run in the d orbital as well. Like there are five, so the name will be dxy, and the second will be dyz, dzx, and dx square, y square, and dz square. So let us discuss about p orbital. Let us assume this is px orbital. This one will be, we are assuming px. This one we are assuming as a py orbital. But last but not least, this one we are assuming pz orbital. So I already mentioned that in the px orbital, the electron will lie only in the x axis. So let us assume this one is x axis, this one is y axis, and this one is z axis. As earlier, if this portion is plus x, then this will be definitely minus. This will be plus, then this will be minus, and z, this is plus z, so this will be minus z. So this is the x axis. So here the electron will lie. Here will be the dumbbell shaped orbital. Let me show you. Like in this portion, there will be dumbbell, and in this green portion, the electron will lie. Apart from that, there will be no electron. I'm highlighting this portion as well. Like at this portion, you can find the electrons. If I talk about on the y-axis, can you find the electron? If I'm talking about the px orbital, only on the red portion you can find the electron. Here there will be no electron. On the z-axis as well, there will be no electrons. Only in the x-axis. If there is a question in the examination that in the px orbital on the which axis you can find the electron, the answer must be x-axis. Let us talk about the py. If I talk about py, you can see here py. So the electron will lie in the y orbital, but before that, let me draw. This one will be x-axis, this one will be y-axis, and this one will be z-axis. So I will draw in the y region, like here the dumbbell, and in this portion you can find the electron. I will highlight this portion as well. Like in this light green portion, you can find the electrons. But the thing which you need to understand that, like in the py orbital, only in the y orbital electron will occupy. If you ask me that can you find the electron in the x-axis, then I will say no. In the z-axis, no. In the y-axis, definitely yes. So as previously, this one will be the y, this one will be the x, and this one will be z. So if I talk about this, like you can find electron on this black pen region, you cannot find on the x region and on the pencil region. So this is y orbital. Now let us discuss about the last one, that is z. So as always, this portion will be plus x-axis. So this one will be minus. This one will be plus y portion. So this one will be minus y. And if you are assuming this portion as a plus z, so this one will be minus z. Now the thing is that you need to draw again the dumbbell on the z-axis here. Now it's quite complicated when you see the z-axis because it's not in the plane, so it's little bit hard if you are like seeing this first time. I will describe with the light green color that you can find the electron in the z-axis. It's very hard to find in the other axis like x-axis and y-axis. So I'm trying to say the similar thing. Red pen is x-axis, black pen is a y-axis. So on both the axes you cannot find the electron. Like in the whole plane you cannot find the electron, but in the z-axis, the pencil region, that like above you, like you can see this pencil like towards the observer and away from the observer. So in this region you can find the electrons. So this is the basically structure of the p orbital. Now let us see the structure of d orbital, but before that let us see little bit theory as well. And I just forget to teach you one thing that I was saying about the energy level. Just give me 1 second. Energy. So I already mentioned that in the energy level, d orbital is having the highest energy, and if you are considering f orbital, then it will be having the highest energy. It will be having the highest energy. Then there will be d, then there will be p, and then there will be s. So s orbital will be having the minimum energy, then p orbital, then d orbital, and then f. So when we switch to s orbital to p orbital, and when we move to the higher orbital, then the energy increase. I totally agree with you, but the thing is that stability decreases. The stability is definitely going to decrease because both are inversely proportional. So I will make opposite one, that S will be having the highest stability, then P, then D, and at last there'll be F. So if I like just make a relation between the stability, so it will be like this. Like here will be the energy, and just second, and here will be the stability. It will be inversely proportional. Stability, stability. The thing is that, like if you increase the energy, if I'm increasing the energy, then stability will definitely decrease. And if you are like decreasing the stability, it means you are increasing the energy. The thing is that if something is directly proportional, so it will follow the principle that if the energy will increase, then stability will increase. But if it's someone is like the inversely proportional, like the below the power, then it will be quite opposite thing. So you need to understand both of the thing. Now let us move to the d orbital. That one is our last topic. Just give me 1 second. Atomic orbitals we already finished. Atomic subshells p d. So here is a d orbital. So we already mentioned that d subshell there will be 5 d orbital with the name dxy, dyz, and dzx, and dz square and dx square y square. So these orbitals having a like complex shape irrespective of s orbital and p orbital. S orbital and p orbital are quite easy, but when we discuss about the d orbital, it will be quite complicated. But we need to understand this one as well. And the energy of the d orbital, we already mentioned that it's much higher than the s orbital and p orbital. But the stability, that will be below from the s and p orbital. We already mentioned, like you can see here, that the stability of S is maximum and then D is minimum if you compare SPD and F. So if I see the structure of D orbital and if you draw the X, then this time the electron will not be found on the like the x-axis, y-axis, and d and z-axis as you are finding in the p orbital. You can find dz square on the axis. The thing is that dx square y square on the axis, but not dxy, dyz, and dzx. You will find between the axis. Like if this is y-axis, this is x-axis. So you will find between the axis. I will describe you this thing with a diagram. Just give me 1 second. So this one is the line. So this is y-axis. This portion will be the x-axis, and this portion will be z-axis. Let us not draw the z-axis right now because there will be no use. Axis we can take by our choices. Like it totally depends on me, on you. Because if you assume this one is y-axis, that is also fine by. Because if you are assuming this one is y, so then you have to assume another one by x and z. Because both the three are at 90 degree, that you can already see. There's a 90-degree angle between them. You can see 90-degree angle. I'm just copying this thing so that we can do the 5 dxy, dyz, and dzx. This will be dz square. This will be the last one. Okay. So if I'm like talking about the dxy, so let us assume this one is x-axis, this one is y-axis. All the things are same regarding the axis. If this one is plus, then this one is again minus. This one is plus, then this one is minus. But the thing is that right now this one will be dxy axis, and right now the electrons you cannot find on the x-axis or y-axis. You have to draw orbitals in between. The shape of the d orbital basically double dumbbell, not a single dumbbell. It will be double dumbbell. Like you can find this portion between the x-axis and y-axis. This is the one dumbbell, and this one is another dumbbell. Just a second. This one is another dumbbell. So if I like color this portion for the better clarity, then I will color like this one, this one, this one, and this one. So as I already mentioned that you cannot find electron on the axis, you will find between the axis. So if this one is the y-axis, this one is the x-axis. So you this time you will not find electron on the x-axis and y-axis. This time you will find electron in this mid portion. In here one lobe, and here there will be second lobe. If I compare with the like p orbital, then you can see only one lobe is there. The complete one is one lobe, but like one dumbbell, that will be more better. One dumbbell, but here you can find two dumbbells. So that's why the shape of the d orbital is double dumbbell. Shape of s orbital is spherical. Shape of p orbital is dumbbell. Shape of d orbital is double dumbbell. Let us describe the dYz portion. YZ. So I can assume I already mentioned you that you can also assume this one is the y portion or z portion, whichever you want. So I'm assuming this one is y and this one is z portion. So when I like draw, it will be like similar like dxy that just a second, it will be dark color. Okay, it is already dark. Here it will be like between the axis, not on the axis. One dumbbell and another dumbbell will be here. It is not too much correct, like this. And if I color this portion with the light green, then you can see this portion where you can find the electron. This portion you can find the electron. And if I will say that please find the electron for me on the y-axis, I will say no, it's not possible on z-axis or with the x-axis. Right now you can see like now this is not the x-axis, no more, this is y-axis. So I will point by this one, and this one is the z-axis. You can see on the screen, and the remaining will be like the x-axis will be here. Okay, so if I will tell you on the find the electron on the x-axis, y-axis, or z-axis, you cannot find, but you can find the electron between the x and y, like between the y and z portion, because this is dyz. If I describe the last one, that is not the last one. There are two more to go. After that, like this is zx. So I will clearly say that this is the x region, x-axis. This is the z-axis. Like there are five, that is xy, yz, and zx. So like this will be the x portion. So if I like try to draw the orbitals, I will choose the dark green color again, and here it is. Here you can find, I will also color this by like green, this one, this one, this one, and this one. So these light green are the portion where you can find the electrons, and this is the maximum probability of finding the electron. The thing is that you need to understand that you can find electron in this region, but you cannot find electron on the x and z axis. Let us study the last two more. That is, one is the dz square. Just a second. And one is the like. Let us assume this one is dz square. Dz square. So if I like, I have to assume this one is the z-axis. This one is the x-axis. If this portion is plus x, this one is minus. This is plus z, so this will be minus z. So what happened in the z-axis? So it will be quite different. That electron lie in the towards the z orbital, like towards the z-axis. Like I already mentioned that dz square and dx square y square will be quite different. The electron you can find on the axis irrespective of dxy, dy's, and dzx. I will color this portion with the light green. So And apart from that, one thing I'm missing to draw a ring here. Like here, there will be one ring. Okay, and you can find electron in this position, like here, here. This is the reason where you can find the electron. I already mentioned that on the dz square you can find electrons on the towards the z-axis. Okay. Now let's study about the last orbital, that is the dx square y square, dx square y square. So it is also like quite similar. You can see the x orbital here. This will be plus x, so this will be minus. If this one will be plus y axis, this will be minus y axis. Now what you need to understand on that, like only on the dz square and dx square y square, you can find the electron on the axis. Apart from that dxy, dyz or dzx, you are finding electron between the axis. So that is the quite difference between them. So if I will draw the electron on dx square y square, it will look like this. One dumbbell here, it will look like bigger second, and the second dumbbell on the axis. So if I color the portion so that it should look more better and it should be more clear to you. So this portion you can see that this light green is the portion where you can find the electron on the axis. So this is all about the x-axis, y-axis, like s orbital, p orbital, and d orbital. So basically, what we understand from this lecture, that electron have two properties. One is the particle and one is the wave. So it's very hard to locate the electron location. So that's why like the orbitals are the reason where you can find the electron. There is a maximum probability of finding electrons in the orbitals. The nucleus is the portion where you can find protons and neutrons, and both combine and form nucleons. Orbital is the reason where you can find the electrons. There are three types of subshell: S, P, D, and like F. And in the S subshell, there will be like one orbital. In P, there will be three orbitals. On D subshell, there will be five orbital, and on the like F subshell, there will be seven orbitals. We had named the like S stand for the spherical, P stand for the principal, D for diffused. And if I see the orbital, one electron will occupy the plus half, then another will be minus half with the opposite spin. S orbital have the spherical shape. If I talk about the p orbital, then its shape will be dumbbell. If I talk about the d orbital, then its shape will be double dumbbell. If I see p orbital, there will be three. The name are px, py, and pz. If I talk about the d, there will be five: dxy, dyz, dzx, dx square, y square, and dz square. Okay, you can see here as well. And like I already described as orbital, you can find the electrons in the spherical region. Px orbital you can find in the x-axis. Py orbital on the y region you can find on the pz. You can find electron on the z-axis. If I talk about the energy level, then like the if the orbital is changing and then the energy level is increasing, but the stability is decreasing, because stability and energy are quite different thing. They are inversely proportional. If the energy is increasing, then stability is decreasing. If I talk about the orbitals dxy here, dyz and dzx, so you can find electrons in between the axis in the d orbital and dyz as well, dzx, but dz square and dx square y square is quite different. You can find electron only on the axis like z, and you can find on dx square y square on the x and y axis. So this is all about the today's lecture, and I hope you enjoyed the lecture. Guys, this was like my first video on the YouTube, and I'm not saying to like my video or subscribe to my channel, but if you think like anything is missing in this lecture, please mention in the comment box, and please also see if I'm doing any mistake, then you can point out that one as well. And thank you for watching this video. Thank you so much.